Hello and welcome. So we will be looking at the expression for efficiency of an Otto cycle. And because this question is mostly asked in an exam, and be asked to derive the efficiency. So you will start by drawing the PV diagram and the TS diagram. All right. So what is the formula for efficiency? Efficiency of an Otto cycle is denoted by this. So you can just write Otto here. Everything is equals to what? Work done all over heat supplied. So that is it. And you are going to note that our work done is heat supply minus heat rejected all over what? Heat supplied. All right. So you are going to note that our quantity of heat is supplied at constant volume, and our quantity of heat is rejected at also what? Constant volume. So if you look at the diagram here, we have our heat supply at what? At process 2 and 3. 2 and 3. It is constantly supplied at process 2 and 3. So Q of S there. QS. So the formula for QS will be equals to CV into what? CV into into T3 minus what? T2. T3 minus T2. All right. And our QR is equals to what? CV into what? Into and it is rejected at where? It is rejected at T for process what? That is 4 to 1. So this is 4 and 1. So it's going to be T4 minus T1. T4 minus T1. So you don't need to cram. Is that clear? All right. So now the next thing we are going to be doing is we are going to substitute this formula in this formula that we have here. So we are going to say, I don't know if this place can still contain it. Let me manage the space. All right. So we are going to have Otto will be equals to QS here is what? CV into T3 minus T2 minus CV into what? Into T3 minus what? Sorry, into T4 minus T1 all over what? All over CV into what? T3 minus T2. All right. So now we can rewrite this as this. Say that Otto efficiency of minus T2 all over what? All over CV into T3 minus T2 minus CV into T4 minus T1 all over what? All over CV into T3 minus T2. All right. So if you do that, you observe that this will go with this. So we can therefore say the Otto's efficiency will be equals to 1 minus CV will go with CV, T4 minus T1 all over what? All over T3 minus T2. All right. So this is the formula for an efficiency. So we can still further modify this formula. But before we do that, you are going to note that our compression ratio, we have compression ratio, we have expansion ratio. Of course, compression ratio is also the same thing as what? Expansion ratio. All right. So let's look at our compression ratio. Our compression ratio is denoted with this, which is equals to what? V1 all over what? V2. V1 all over V2. And then we said we also have expansion ratio, which is what? Expansion ratio is what? V4 all over what? V3. V4 all over what? V3. So we said both of them, they are equal, right? They are the same. So we can therefore say compression ratio is equals to what? Expansion ratio. Let's everything be equals to what? ER. Exactly. All right. So let's leave that. So now the next thing we are going to look at, we are going to go to process 1 and 2. From process 1 and 2, we are going to relate temperature and volume there. All right. So let's go to process 1 and 2. From process 1 to 2. From process 1 to 2, we know that process 1 to 2 is nothing but what? It's nothing but an adiabatic process, right? So if you want to relate temperature and volume there, it's going to be T2 all over T1 to be equals to what? To be equals to V1 all over V2 all to the power of what? Gamma minus 1. And we just stated that V1 all over V2 is nothing but what? Compression ratio, which is what? R. So we can replace this to be equals to R to the power of what? Gamma minus 1. All right. So now let's equate. Let's make T2 the subject. If we make T2 the subject, it means T2 will be equals to T1 multiplied by compression ratio to the power of gamma minus 1. All right. So that is what we are going to have. Now let us go to process 3 and 4. Let's go to process 3 to 4. So from process 3 to 4, let us also relate temperature to what? To volume. So if we relate temperature to volume there, we know that we are going to have T3 over T4, T3 all over T4 to be equals to what? To be equals to V4 all over V3 to be power of gamma minus 1. Now, if you look at this, we already established that V4 over V3 is nothing but what? Is nothing but compression ratio. So we can replace these two with compression ratio to the power of gamma minus 1. All right. So we are going to make T3 the subject here. So if we make T3 the subject, T3 will be equals to T4 multiplied by what? Compression ratio to the power of gamma minus 1. All right. So now we are going to substitute T2 and T3 inside this value that we have here. So we are going to have our efficiency of Otto cycle to be equals to 1 minus, we're going to have T4 minus T1 all over what? All over T3. What is T3? T3 is what? T4 into what? T4 into gamma to the power into the R minus 1 minus and T2. What is T2? T2 is what? T1 into what? Compression ratio to the power of gamma minus 1. So we can say this is equals to 1 minus T4 minus T1 all over. Now if you look at this, something is common. Compression ratio to the power of gamma minus 1 is common. So let's bring it out. Compression ratio to the power of gamma into, we left with T4 minus what? Minus T1. All right, I believe you are following. So now this one, now we go with this. So we'll be left with our efficiency of Otto cycle will be equals to 1 minus 1 all over what? Compression ratio to the power of gamma minus 1. So this will be the formula for efficiency of an what? Otto cycle. So it's either you use this or you use this, but I think most of the time this is the one we use mostly. Is that clear? So if you are asked to derive an expression for an efficiency of an Otto cycle, this is how to go about it. So thank you, peace and love.